So last 5.4 was the last lesson we have. In this class, we're going to do 5.5 and 5.7. But I do want to make sure that you know that some of these problems on 5.4 are just a matter of you can type them in the calculator. So I'm going to go back to 5.4 for just a minute, especially if it's just all numbers, okay? So if you've got variables in there, it's going to be a little bit more difficult. But if my problem, and a lot of these are on the My Math Lab, on 5.4, if my problem is just as simple as 3/4 plus 2/5 over 1/2 plus 3/5, it's perfectly fine to work it the way that we did in class. But the easier way, if you have no variables, is to just type this in the calculator. Go use that alpha y equals button and get your fraction to come up. Type in 3/4 plus 2/5. And you would get an answer to that. That answer would be 23 over 20. And then on the bottom, we would add 1/2 plus 3/5. And that's giving me 11 over 10. And then you could just take and divide those. So 23 over 20 divided by 11 over 10. Okay, and I'm coming up with 23 over 22. So that would be the easiest way on 5.4 if it is just numbers and you're not having to do anything else. You don't have any variables there. So I just wanted to point that out. Now, if there's variables there, you're going to have to work the problem like we worked it, or you're not going to be able to come up with the right answer. But if there's just numbers, you should be able to be fine with this. So let's go ahead and go to 5.5. We're going to do 5.5 and 5.7 today. So on the notes on 5.5, I'm going to skip past the example that they've given, but the first problem is that they want us to solve 3/8 plus 1/3 equals x over 12. Okay, well, if this is my problem and they're asking me to solve this, well, the first thing I'm going to do is I could consolidate this fraction. I can type in, or I can figure out what 3/8 plus 1/3 is by just using my calculator. Can get that down to, and again, on the graphing calculator, you hit alpha y equals to get your fraction. But that's going to get me 7/8 is equal to x over 12. So I really need x that we're asked to solve this. So that means we need to get rid of this divided by 12. And to get rid of a divided by 12, you would multiply by 12 on both sides of your equal sign so that these 12s cancel out. And so our answer would be 12 times 7/8, which is 21 over 2. If we wanted the decimal form of that, it would be 10.5 is equal to x. Now, if you get this in your calculator and you want it to convert it to a decimal, you just hit math, enter, and it'll change it for you. It'll change it back and forth from a decimal to a fraction. Okay, so let's look at the next problem. Solve x over 3 minus x over 3 is equal to 12. Okay, so if you've got x over 3 and you subtract x over 3, okay, well, that means that you've got 0 is equal to 12. Well, this is not true. 0 is not equal to 12. And this would be no solution. There's nothing I can plug in there for x that's going to make that equal to 12. So no solution. on that one. Okay. Solve 2 over x minus 1 over x squared is equal to -3. In this problem, we can't just put these two together because they don't have a common denominator, which we've been working a lot on finding a common denominator. Least common multiple is what we need to find in order to make this work. So least common multiple of these two, what you want to do is focus on the denominators. So we're really focused on the x and the x squared. So those are the two things that we're kind of comparing. We want the least common multiple of those two, x and x squared. Well, you know that you listed the most amount of times it's in either group. So x squared would be our least common multiple. Now, similar to how we did in 5.4, you want to take that x squared and you want to multiply it by every single thing. So we want x squared. And the reason that we're doing this is because it's going to make some of these things cancel out and consolidate, which you'll see in just a minute. But I'm multiplying every single thing by x squared, even after the equal sign. So on this side, we would have -3x squared. Okay, on this side, we have, and I'm going to go slow on this, we've got 2x because we want to take this x squared and multiply it by both of these things. So we've got 2 over x times x squared. And then we've got 1 over x squared times x squared. Okay, so we took x squared and multiplied it by both of these things. Now, you should be able to start recognizing that some of these things will cancel out. In other words, this is really x to the first power. So this x to the first power will take away one of these x squareds, which would leave me with 1 left. So this whole thing, when I multiply it, all I've left with is 2 times x to the first, which is just 2x. Okay, when I look at these two, when I multiply them, well, I've got an x squared on the bottom and an x squared on the top. So those cancel out, and all I'm left with is -1 equals -3x squared. Now, we've seen things like this before. This x squared is quadratic, right? So that means that it's going to end up, the answer when we find it, we're probably going to have something that looks like this factored thing that we've been working with before. Now, it's fine if you use the calculator to find the answers, but, and I'm going to show you both ways just to kind of remind you, but the first thing that you need to do is you need to have this equal to 0. So I need to solve a quadratic, you need to have it equal to 0. So I'm going to add 3x squared to both sides so that this side just turns into 0. And usually we list this in the order, x squared, x to the first, and then our regular number at the end. And when we solve that, we would come up with something like this. It's been a couple of weeks probably since we talked about this, but the way that we solve it, remember, if you have a number in the front, you do 3 times whatever's in the back. Okay, and 3 times -1 is -3. So this thing turns into -3. And this is 2, which comes from right here. So we want two numbers that add to -3 and, multiply to -3 and add to 2. Well, those two numbers are going to be 3 and -1. Now remember that we're not done here because we've got this number in the front and we need to divide by that number. So, and then reduce our fractions. Well, -1/3 is reduced. Okay, so that would be, remember you put the numerator or the denominator in the front and then x, and then you do the opposite of whatever here is here. So if it's -1, you're going to put +1. Now 3/3 is just 1. So when we reduce that, so that would be 1/1. So we would have 1x, and then you do the opposite of whatever's on the top. Since it's a +1, we would do -1. And then you would solve this. solve both of these, and this would give you the answer. So on this one, we would subtract 1, divide by 3. So that's x is negative 1/3. On this one, we're adding 1. So x is 1. So we've got x is 1 and x is negative 1/3. Those would be the two answers. Now, I'm going to go just because maybe you missed it on another lesson, but we can just use the graphing calculator program to solve this 3x squared plus 2x minus 1. If you don't have this app on your calculator, if you bring it by my office, I'll be glad to put it on there for you, or bring your calculator to class. I can do that for you as well. But I'm just going to use I'm going to go show you on the calculator what the app is. 3x squared plus 2x minus 1. So we go to, on the graphing calculator, you go to apps, and you want to go to the very bottom one, number 9. So you can either hit 9 or use your arrow, doesn't matter. And then we do want the polynomial root finder, so I'm going to hit enter. This has, it had 2 roots, okay? So I'm going to hit next, which you hit the graph button. Whatever button is underneath here is what you want to push to get it to come up. So I think it was, let me go back. So it was 3x squared plus 2x minus 1 that we want. So we would go in here and type the stuff in. 3, enter, x squared plus, enter 2x, enter, minus, enter 1, enter. And then we want it to solve, and the graph button is right under solve. So we put enter. And so our answers, it tells us the answers, 1/3 and negative 1. And if we go back and look at our problem, so that, again, that was under apps, and it's the poly root finder that you're looking for. So when you go to apps, sorry, let me get out of this. I can quit. When you go to apps, you want to go to 9, the poly simulator number 2, and then you're going to do the first one on that choice. So we got the same answers that we had right here, negative 1/3 and 1. And I just want to make sure that you're able to do that. Because the calculator can help you out a lot. So let's clear this out. So the next problem, we've got 3 over y plus 7 over y is equal to 5. This problem's kind of nice because this has the denominator is exactly the same. And when the denominator is exactly the same, all you have to do is add them. The denominator is going to stay whatever it already was. And then we've got 3 plus 7, which is 10, is equal to 5. Well, we want this y to not be on the bottom because it's very difficult to find what the answer is if it's on the bottom. Now, you could probably brainstorm this one and figure out it's 2, right? Because 10 divided by 2 is 5. But to work this with algebra, right, we want to get the y to move up to the top. So we would have to multiply both sides by y. That would make that y cancel out, and we would get 10 is equal to 5y. Now we want y by itself, so we're dividing both sides of the equal sign by 5. These cancel out, and we get y is equal to 2. Okay, and so that's going to be our answer. Y is equal to 2. That one was not bad at all. Okay, we have 2 more problems to talk about in 7 and 5.5. Okay, so solve 1/2 is equal to z minus 5 over z plus 1. Okay, Well, one thing I'm noticing right off the bat here is I can't have that Z being on the top and the bottom and figure out what this is. So this is not the only method, but this is the first thing that I would want to do if I was solving this problem. When I see an issue like this, we can use something called cross multiplication. And in cross multiplication, it is exactly like it sounds. You take the numbers that are across from each other, the 1 and the Z plus 1, and you multiply those. So 1 times Z plus 1. Then you put an equal sign. Then you take the other numbers and that are across from each other and you multiply them. So you have 2 times Z minus 5. Okay, now it wouldn't have mattered if I put the 2 times Z minus 5 on this side and the 1 times Z plus 1 on this side. That would make no difference. But these things are equal to each other. So when we do the distributive property and get rid of the parentheses, well, 1 times Z is just Z. 1 times 1 is just going to give me 1. Well, then we want to do the same thing with this. 2 times Z is 2Z, and 2 times negative 5 is negative 10. Now we know that we can't have, we're going back to the very beginning of the class, we can't have Z's on both sides of this and solve this. So we've got to move one of these Z's, and it doesn't matter which one. I'm just going to subtract this one. So I'm going to subtract a Z, and now there's no number here, so we know this is 1Z. So this is going to turn into 0, and I'm going to have 1 is equal to 2Z minus 1Z. Well, that's 1Z minus 10. Now I can add 10 to the other side of my equal sign, and that's going to get me 11 is equal to 1Z. So Z is equal to 11. Now I could plug this in and check it, right? If I plug this into this side and check it, I would end up with 11 minus 5 and 11 plus 1. 11 minus 5 is 6. 11 plus 1 is 12. If you reduce that, we have 1/2, which is what we're supposed to have. So we can always go back and plug it in and check if we need to. Okay. Here is the last problem we're going to look at in 5.5. So it is to solve x minus 2 over x minus 4 is equal to 2 over x minus 4. Okay. So I think that it would be appropriate to do the same thing that we did before, because we've got x's all over the place. We really need them all to be either on top or on bottom. So if I cross multiply, okay, if I cross multiply, and I guess another thing I'm noticing that might be a little bit easier is if we just, since there's x minus 4, let's back up. I think this would be the better bet. This would be super easy to solve it this way. You could still cross multiply and solve it. I think it might just be a little bit more difficult, but I need to get rid of these x minus 4s on the bottom. So if we multiply both sides of the equal sign by x minus 4, what's going to happen is these x minus 4s are going to cancel out, and we're going to be left with x minus 2 equals 2. And then, so that's really easy. Now that only works because they were the exact same things on the top and the bottom. So I multiplied by x minus 4 because we had 2 x minus 4s on the bottom and got rid of them both at the same time. And that's x equals 4. Now I will tell you this, there's a lot of different ways to solve algebra problems. So when you're a new student in mathematics, sometimes you have to kind of try something, right? You might be at it at the wrong, going at it the wrong way, and you're realizing this while you're solving the problem. Just like what I was fixing to do with this problem. Because you got to start somewhere, and you're like, well, this is one method that I have, right? I said, well, I could cross multiply and say x minus 4 times x minus 2, and then is equal to 2 times x minus 4. Well, when I thought about that, I could still work this problem. I'm still going to come up with the same answer. It's just going to take me a lot longer than doing it this way. So if I work it this way, I would have thought, okay, well, then this side's going to give me 2x minus 8. Man, I would have probably used the FOIL thing and multiplied this all out, first, outer, inner, last, right? And that would give me x squared minus 4x minus 2x plus 8. So that's going to give me x squared minus 6x plus 8 is equal to 2x minus 8. Okay, I would have gone, oh, we've got an x squared, so I need to get all my x's on the same side. So I would start moving things, and also I need it to be equal to 0, so I would start moving things. So that would give me x squared minus 8x plus 8 is equal to negative 8. So still trying to get this thing equal to 0. So I've got x squared minus 2x plus 16 is equal to 0. I'm looking for two things that multiply to 16 and add to negative 2. Do you see, like, once I realized, oh, there's a lot easier way to do it, of course I wanted to do it this way, because this is taking me a long time. Still going to get me the same answer. So two things that multiply to 16 but add to negative 2. Can we even do that? 4 times 4, new. 2 times, that's going to get me a positive. So we would have been at a stopping point unless I've written down something wrong. Let me eyeball this real quick. Oh, I see what I did. Sorry about that. Negative 6x minus 2x, which is why you want to show your work. Negative 6x minus 2x is negative 8x when you put those two together. So this needs to be negative 8x. So we need something that multiplies to 16 and adds to negative 8 right here, which would be negative 4 and negative 4. So x minus 4 times x minus 4 is equal to 0. And then when we solve that, we would be looking for, well, when is x minus 4 equal to 0? Well, x is 4. That is a long, difficult problem when we could have just done this. So that's why we kind of talk about different methods to solve the problems. It's not wrong to do this method. It's just when I started to do it and I realized, oh, there's something easier. And that just takes practice. Okay, you might even be able to think of an easier way to do it than the easy way I did it up here. Okay, but don't give up just because you can't think of an easy way to do it. Okay, keep going, because we could have worked it this way and come up with the right answer. Okay, there's more than one right way to work these problems. So let's 5.7 is really short. Let's go ahead and take care of that. So it's very similar to what we've been doing, but they're wanting us to solve x over y is equal to w over t, and they want us to do this for y. So what that means is at the end of the problem, they want it to say y equals, okay? And they say solve that for y. They're wanting it to say y equals. So when I'm looking at this, I'm like, ooh, man, I see a fraction right away, and I want to get y by itself. So I think it might be a great idea to cross multiply here. Okay, so x times t, right? X times t is equal to w times y. And I'm not really writing these in any specific order. Most of the time they're listed in alphabetical order when you start dealing with letters. But I need to get y by itself, and right now there's a w times y. So to get rid of a times, we know we would divide by w on both sides of the equal sign. so that the w's cancel out and we get y is equal to xt over w. And so that's the answer. We've got it. We wanted y equals, we've got it. So this was one of those where I recognized, the first thing that helped me recognize what if I needed to cross multiply is that I had two fractions. Okay. So let's look at the next one. It says to solve y equals xt over w. Ooh, that looks familiar. But they want us to solve it for t this time. So they want us to say t equals, that's what my answer is going to be. I don't have a fractions equal to another fraction on this one, so it would not be a good idea to cross multiply. I do know that I'm trying, the whole goal is for me to get t, this letter right here, t by itself. So I could get rid of this w on the bottom because we've got w divided by w. We get rid of a w, that means we would multiply by w on both sides. So we would have wy is equal to x. Now the w's canceled out because I've got one on the top and one on the bottom. xt, that looks familiar because that was one of our original equations from last time. But I need to get t by itself, so I need to get rid of x. In order to get rid of x, it's x times t, so we would do the opposite of multiplying. We would need to divide by x. So that means that this x is going to cancel out with this, and we would get t is equal to wy over x. And we got what we needed, t equals. Okay, so we're moving things around using algebra. We've got two more problems that we're going to look at on 5.7. So we've got 2 over k plus 1 over y is equal to 3. And they want me to solve for y. That means at the end, it needs to say y equals. It needs to say y equals. So that means I've got to get y by itself. So this is, so we're kind of wanting this, trying to get this by itself. I'm kind of focused on that. So I want to go to the side with the y on it. And I need to get rid of this. This term is just an extra thing and it's been added on. So to get it to move, well, I'm going to need to subtract it off. It says it's a positive 2 over k. So to get it to go away and move to the other side, I'm going to need to subtract 2 over k. Because I want to get everything away from this y. I'm going to focus on the things that are on the same side as it and start moving. So that's going to be 1 over y is equal to 3 minus 2 over k. Okay, because those canceled out. Now, this y is on the bottom of the fraction, and in order for me to get it to say y equals, it can't stay down there. So to get rid of a divided by y, I'm going to have to multiply by y on both sides of my equal sign. On this side, this is going to cancel out and I'm going to get 1 is equal to, and you're like, oh no, you got rid of the y altogether, but no, it's still over here. And you got to be careful because this y only had one term to be multiplied by it, but this has, I really have to multiply this y by everything over here on this side. So it's got to be 3 times y, or y times 3. And then also we have to multiply the y times the 2k. And we could have put the y out here, but it doesn't matter where you put it. In other words, I was saying you could write, it's possible to write it as minus 2 over k and then just have this y out here like that. But it really probably, so the y would go with the top. But it's really better to write it like this. Now, here's what I'm noticing about this. I need these two to go together because I need to get this y as one term so that I can isolate it by itself. So this goes back to finding a common denominator. I need to put these together. Right now, the denominator underneath this is just a 1, right? This is just a 1, and this is a k. So I need to multiply. So the only denominator I really am dealing with is k. That would be my least common multiple then. So if I multiply everything by k, will that help me? Well, probably, because it's going to clear out. So I'm going to multiply every single thing all the way through by k. So on this side, I'm going to have a k times 1 is just k. On this side, I'm going to have 3yk. Okay, and then I'm going to go ahead and write this out, minus 2y over k times k. Okay, that's a lot of k's. So what happened with that, let me erase this real quick. Still looking for y equals, so this problem's kind of complicated. What happened with that is that helped us cancel some things out. It got it where my y's are on the top of my fractions and they're isolated. But look at this. This k right here is going to cancel out with this k. So now I've got k is equal to 3yk minus 2y. And here's because both of these terms, and remember our end goal is to figure out what y is. So because both of these terms have a y in it, I can factor out a y and do 3k minus 2. I took a y out of this term. That gave me 3k. I took a y out of this, and I'm left with just minus 2. Okay, now I'm getting close. So here's what we have. We've got k is equal to y times 3k minus 2. I want y by itself, so that means I need to get rid of this times 3k minus 2. So I can divide both sides by 3k minus 2. What's going to happen there is this is going to cancel out with this, and I have y is equal to k over 3k minus 2. And that would be the final answer. I can't think of an easier way to work that problem right now. And that's why I was trying to say you kind of have to have some stick-to-itiveness because there's lots of different ways to work the problems. But there might be an easier way to work this. It just didn't come to me at that time. But you kind of look at all the options, go back and look at other examples when you're working this stuff. Okay, last problem. Solve 1 over m plus 1 over x is equal to 1 over z for m, which means that I need m equals at the bottom. Okay. Man, I could clear out, if I multiplied by our least common multiple, so if we look at our bottom terms here, we have an m, an x, and a z. And I really don't want to have to deal with fractions. And that might have been a good thing to do with the other problem as well. But if I look for the least common multiple among these x, m, and z, then my least common multiple would be x times m times x times z, because I'd have to list all three of them. So if I multiplied everything by m, x, z, each one of these terms by m, x, z, well, what's going to happen is I'm going to get rid of the fractions. Okay, the m's are going to cancel out on this one, and I would be left with xz. The x's are going to cancel out on this one, and I'm left with mz. The z's are going to cancel out this one, and I'm left with mx. Okay, now it's much easier to look at this when they're not all fractions. You want to pay attention to your end goal, which is we need to get the m's. We need to figure out what m is equal to. So it might be a good idea to get the m's on the same side of the equation. Okay, so I'm going to I'm going to move this MZ to the other side so that I can have, on this side, I just have left an XC is equal to MX minus MZ. Now I've got my M's all on the same side, which is what I'm looking for. I can pull that M out. There's an M in both of these terms, so I can pull an M out of both of those. Okay, now I can get rid of the X minus Z by dividing by it, just like we did in the last problem. Those are going to cancel out, and I'm going to get M is equal to XZ over X minus Z, which would be my final answer. So when you get this, you want to see if you can get them to factor out, because if you do, then you're going to be able to isolate that variable and get it by itself. Okay. So you should be getting very close to wrapping up chapter 5. If you're not, that's what your goal should be. I know that it's not due yet, but you want to stay where we're at in class. I will post these videos. I think the notes are already there for you, but that is the end of 5.7.